Brilliant. Here we go. So I'll launch into the presentation. I'll do it in Windows. Yeah, I'll try and keep an eye on the Q&A as well. So feel free to ask any questions in the Q&A. Probably the live streaming one is the best one to target. Brilliant. Here we go. So debugging microservices with telepresence, local to remote hot reload. So the key takeaways for this talk, the TLDR, is the inner dev loop can be painful when you move to microservices and Kubernetes. Microservices, there's just more things, right? More dependencies. We love our modules these days in microservices, hard network boundaries. But when you're working on one service, often you're dependent on other services you want to call out to or services that are calling you. There's also more layers of infrastructure with Kubernetes, right? We got Docker or some kind of container technology, Kubernetes, VMs, cloud, all this kind of stuff. It's just more complicated debugging. Telepresence, open source CNCF tool, proxies your local machine into a Kubernetes cluster. And you can get this super fast feedback loop, as I'll demo a little bit later on as well. I'll set up some context first. Now, Telepresence supports several workflows from small to large systems. If I've got time, I don't know if I will today, but I'll run through some of those workflows. If I don't have time, I'll share the slides and you can get a look. Some folks from Engels and Volkers have shared their workflow. Some folks from lots of other companies have shared how they use Telepresence. And I always find those use cases super interesting. And lastly, it is a cloud native computing foundation project. We are sandbox project for Telepresence. So we really rely on you, the community, to give us feedback, help with docs, contribute use cases, code, the whole gamut, right? So I'm going to enthrall you to, if you like what you see today, put it into your workflow, but please do get involved with the actual project itself. Very quickly, this is me at Daniel Bryant UK on most of the interwebs, GitHub, LinkedIn, Twitter. I love getting involved on Twitter. I'm the director of DevRel at Ambassador Labs now. A lot of focus on Kubernetes. In my past life, I was primarily a Java developer, moved into architecture, operations, written a couple of books with some friends, which do check out on O'Reilly there, and write for InfoQ as well. So my past is very much software development, but these days it's more about building communities and helping folks understand where technologies can help them in their day-to-day work as a developer, as an ops person, as an SRE. So setting the scene. This is a great blog post by Mitch Denny. Unfortunately, it's disappeared now. It's a 404, but there's some references I put down below you can find. And Mitch talked about the inner and outer dev loop as an engineer, right? And the inner loop, if you're doing TDD, this is where you're doing your red, green refactor, right? You're sort of building code. You may be mocking, stubbing, testing, super fast feedback loop. Is my function, the thing I want to do, working? Once you get it working, then you move to the outer loop, right? You're committing to Git typically, you're doing integration tests. In microservices, this typically means you're doing tests against other services, other dependencies too. And then you release, maybe canary releasing, you deploy and you operate and so forth. Now, when I was doing my Java career, like back 20 years ago, showing my age, right? But I coded for like 10 plus years. When I was working on monoliths, the inner loop was super simple, right? It was typically test-driven development, super fast feedback loops. If I had to spin something up, I used to get hot reload. Shout out to the zero turnaround folks back in the day. I'm doing lots of great work on like live reload, things like that. But I didn't have other dependencies. So that inner loop was super fast. Now, obviously, with microservices, you can still mock, you can still stub, use test doubles and go really fast. But there comes a point on the inner loop where often you're dependent on other services and you just need to see how they work. And part of your fast feedback loop is now you being dependent on those other services. Bit of a challenge, right? So we want to see how we can incorporate some of the ideas from the outer loop into the inner loop. And with the inner and outer loop in Kubernetes, it can be the same, which is interesting, right? So you're writing code in Kubernetes land, probably I'm going to show IntelliJ in a minute, a bit of Java code. Maybe you're using, a Vim or whatever, writing Go code. You then build the container, you push to a registry in your cloud, Docker Hub, that kind of good thing, and you deploy to the cluster, and then you test, right? And that loop can be quite slow. If you really want to test against all your dependencies running somewhere else, you go through this loop every time, coding, building container, pushing to registry, deploying to cluster, test. I've made a mistake, go back through, put a new print line in, right? It's the standard kind of joke. Automation can help. There's a bunch of great tools out there. My ex-colleague now, and I know Peter's actually at Container Day, so Peter O'Neill, hat tip Peter. We did a lot of talking around Scaffold as a tool from Google, open source tool, can help do a lot of what I just showed on the previous slide, but in an automated fashion. So when you're coding away, behind the scenes, Scaffold is building a container, pushing it up to registry, making that testing in the remote cluster based on your local changes that much easier. So Scaffold, super interesting tool. There's others, there's Garden, there's Tilt, there's GitCube. I think Draft is kind of a bit defunct now, actually. Octeto are doing interesting things. There's many interesting OSS projects and interesting companies where they're trying to automate some of the pain we saw on the previous slide. But sometimes you just want that really fast in a dev loop, right? You don't want Docker involved, no Docker build, no Docker push or similar other container technologies. You don't want to be building the containers. You want to be running stuff locally in debug mode, maybe in your IDE, and integrating with the remote applications, remote services that you're dependent on, doing that super fast feedback loop. And you want to use your own tools, right? Like I'm a big fan of IntelliJ, regularly use IntelliJ in debug mode, but other tools, database tools, I want to run locally. I want to integrate with remote databases as part of my tests to manipulate data, verify data, all these kind of things. So it's very tempting to want to run everything locally, right? Spin up Minikube, spin up Kind. Maybe if you can't run your whole application locally, you're running a subset of services locally. Gets a bit gnarly, that one though. Docker, fantastic desktop tool, right? Minikube, MicroK8s, K3s, there's many solutions you can use to spin up local Kubernetes clusters. But it only gets you so far. And the biggest challenge I find in the Java world in particular, right, and .NET's kind of similar, is even though I've got quite a chunky laptop here, quite a high-spec laptop, there's only so much stuff I can run locally before my laptop just smokes. And you can probably hear that even with just OBS running and PowerPoint, right? My laptop is already, the fans are wearing away. So there's only so much you can physically run in your local machine to get that fast feedback loop. Enter Telepresence. This is, open source tool, been around now for 4 or 5 years, I think. It's one of the reasons I joined Ambassador Labs as a company. I was really enjoying working with, using the tool, and now it's gone through a couple of iterations, and the community has been fantastic. Contributed ideas, contributed code. Recently, Telepresence has been rewritten using Go. It used to be Python, and it's just gone from strength to strength there. I've heard Telepresence referred to as a fancy Kubernetes VPN for development. I've also heard it referred to as kubectl port forward on steroids. Anyone who's used kubectl port forward. I've also heard it kubectl proxy all the things, like you can kubectl proxy into the Kubernetes API, right? You can proxy all the things here. And it's also a network bridge between your laptop and the Kubernetes cluster. And that's the fundamental thing, right? It literally sets up a two-way network bridge between your local machine and a remote cluster. So you can get traffic going both ways. I'll show you in the demo in a minute, we can look into the cluster from a remote machine, and also we can reroute, or we call it intercept. You can intercept traffic in the remote cluster to your local machine as well. Super useful when trying to get that fast feedback loop. Just to set the scene, I'm going to use a demo today. I've got a Kubernetes cluster up in GKE. It's got 3 services and an ingress. And I'm using the Ambassador Edge Stack for the ingress, community ingress based on Emissary Ingress, which is a CNCF open source incubation level project. So Emissary Ingress, Ambassador Edge Stack adds a few things on top, such as authentication and rate limiting, things like that. I've got my ingress. I've got my very large Java service building like the web page that's going to be rendered. The Java service calls out to the data processing node service, and the data processing node service in turn calls out to the very large data store to get some data. Now, the very large Java service and the very large data store are kind of synthetic. Like I can share the code. Well, the code's already in GitHub with you, so you can have a look at the code. But the idea really is to show a typical microservices kind of chain, right? I want to work on this data processing node service that's in green here, but it's called by another service running in a remote cluster, sorry. And maybe that service is just too big to run on my local machine. And the data processing node service is dependent to get data on this very large data store running in a cluster too. Now, really, I want to get that data processing node service running on my local machine so I can do very fast iterations on code. And this is where Telepresence helps. Now, this is the actual, I want to put it there on the animation. This is the actual architecture of Telepresence. So looking again, we've got our 3 services in the mix, got our ingress, right, our local machine here. Telepresence installs a traffic manager as a deployment, and that manages my connections into and outbound from the cluster, my network connections. If you've used Telepresence 1, there was some slight challenges with getting disconnected and the way we sort of, the way the mechanism worked with Telepresence 1, it actually swapped the deployment under the hood, and that could cause challenges. Whereas now we've actually gone to a sort of permanent traffic manager that manages all the connections. If I get disconnected, I'm on the train coding away, running Telepresence. If I get disconnected, not a problem. It reconnects automatically for me with the traffic manager. The secret in terms of that intercepting of traffic, right? If I want to say now reroute some traffic from that very large Java service to my local machine to do some debugging, we just use a sidecar. And it's actually an Envoy proxy. Anyone probably familiar with the cloud space? Envoy is everywhere, right? Envoy is actually powering the emissary ingress, Ambassador Edge Stack. Envoy powers things like Istio. Envoy powers things like console service mesh. Envoy is just amazing networking technology. It is the kind of de facto cloud native proxy. And we have put, with Telepresence, a proxy in front of our service that reroutes traffic to my local machine. And it can do it selectively as well. It's not in the open source version, it's in the community edition, but with the OSS version, you can reroute all traffic to your local machine. So it's kind of a binary thing. You're either not routing traffic or you are routing all the traffic. And with the community edition, which I'll show you how to work with, you can selectively route traffic based on headers as well, which is super interesting. So that's pretty much it. So imagine a request going through, hits ingress, goes through to my very large Java service. Very large Java service calls out to the data processing service. With Telepresence in the mix, that gets routed to my local machine. And from my local machine, I can call into the very large data store, manipulate the data, and then return the data back through to the very large Java service for rendering. Demo time, right? Perfect. Let me just quickly check if there's any questions on the stream. Not that I can see, I think. Pretty good. Super. Let me now fire up my terminal. So you can see here, hopefully that looks good on the stream. Hopefully you can see here, I'm using kubectl. I've aliased to K just for ease of use, right? K get services. These are the 3 services we just saw on the slide. And of course, the Kubernetes service is always there too. The 3 services in the slide. I can show you, I've got a mapping, a host I've exposed. If I just do K get, get host to expose the Ambassador Edge Stack hosts. Oh, and of course it is in the namespace Ambassador. Put that one there. You can see I've got Frosty Cohen 2352. So that's my URL. Let's bring up Chrome. If I hit the endpoint here, Frosty Cohen, this is the web page. It's a bit meta, right? The web page is actually showing the architecture of the services that are powering that web page. From familiar, ingress, very large Java service, data processing service, calling out to the very large data store. Now, I'll fire up Telepresence. I've set the scene, right? We've got our cluster set up. We've got our services. We know the endpoint we're going to hit, the domain name. If I now do Telepresence connect, it asks me for my password because it does some networking magic under the hood. But we're launching the Telepresence daemon. We're installing that traffic manager in the cluster, and now we're connected to the context, right? So I'll just clear my screen, just make it easy. Straight away, with Telepresence being connected, if I just do status, you can see we are connected. There's a bunch of other things up top here. We can map DNS selectively. I can cover that in the questions if we want to go into that a bit more, but it basically means I can access a bunch of IP address range CIDR blocks in a remote cluster. I can also access the domain names in the cluster as well. But let's keep it simple for the moment. I'm connected into my cluster. So already I know if I just do K get service, right? We know we've got a data processing service and it's running on port 3000, right? So if I just clear that, if I now do curl data processing service dot default, in the default namespace, right? Port 3000. I know there's an endpoint called color, and that's actually, you see the green color in the background. This comes from the data processing node service. So if I curl that, I get green back. Does that make sense? So I'm curling the service name and the namespace name. Data processing service dot default port 3000. I know it's running on /color as my endpoint. So I've set up that network bridge. If we weren't running Telepresence, this would make no sense, right? There is no default sort of domain name, fully qualified domain name. There is no concept of a data processing node service, or a data processing service. Because I've fired up Telepresence, I'm connected into the cluster's namespace. I can curl, I can access MySQL's running in the cluster. I can now access MySQL using my local command line utility. I've now mapped that network namespace into my local namespace with some DNS magic. This is super useful already, right? You can imagine very fast feedback. I can be looking at data stores, seeing what's going on. I can curl endpoints in the cluster, and I can curl multiple endpoints, right? I don't have to do kubectl port forward for every service I want to look at. Now I can just do curl service name dot namespace. Simple as that. But that is not the really interesting thing. The really interesting thing is if we want to spin up some services to do some debugging, right? So if I now, I'll fire up here IntelliJ. I've got IntelliJ running here. I'm running it, I will in a minute run a local copy of the data processing service just in IntelliJ in debug mode, right? I'll click the debug button up here. It's a standard Spring Boot app. You're into Java. Nothing too fancy. Running that locally now. Of course, I've got all my services running in a remote cluster. And now I've got the data processing service running locally, which I want to work with. So what I want to do is I want to reroute traffic. If I hit the main endpoint, the remote endpoint, I want to reroute traffic to my local machine for the data processing service, send it back into the cluster, get all my other data, manipulate it, and then return the results back to the user. So I do this in Telepresence by doing Telepresence intercept name of the service, so data processing service, and I know it's on port 3000. It should detect it, but just to be safer, I'll do that. Telepresence words away and says, we're all set now. We've set up an intercept from the remote cluster to your local machine. Now, if you look in my local version of data processing service, I've set the color here. The app default color might be a bit small, but I've set it to blue, right? And if we look at the initial version, when I was running it, the color here is green. Green title, green box here. If I now click refresh, yeah, fingers crossed, we see some debug wearing away on my local machine here, and I see the color blue. Does that make sense? I'm hitting the main remote ingress that's running in a remote cluster in GKE. The traffic is going through to the very large Java service. It's now being intercepted by Telepresence, rerouted to the data processing service running on my laptop, and I can get this very fast feedback loop going, right? Now, because I've run this in debug mode, if I pop back to my application, I can set a breakpoint, for example, in my color. If I now hit refresh, again, I'm refreshing the main endpoint, right? Breakpoint hit, boom, pass it through. As long as I've got a timeout set quite loosely on my ingress, I can see the results of any changes I make. So I won't do any code changes here, but if I just hit refresh again, I've got access to all my variables, right? All my watches in IntelliJ. I can alter the color. I've got it here as blue. If I just set it to now orange, just an example, right? Hit return, pass that through. And because we know we've got an orange config set up in the web app, I'm getting that fast feedback loop. So all of this, bar the data processing service, is running in my remote cluster. The only thing I'm running locally is my data processing service in debug mode. But I can intercept traffic from my very large Java service to my data processing service. And I can also, from my local machine now, call into my very large data store, and I can manipulate the data in debug mode. Super fast feedback loop. No need to Docker build, right? No need to Docker push. I just get that super fast feedback loop. So that is the core of Telepresence functionality. And the OSS functionality, you can literally spin that up, play around with it today. Happy days, right? If I now show you the next level, we've got Community Edition. You can sign up. It's free. There's extra functionality added on top in the Community Edition. And it allows you to create what's called personal intercepts. Because at the moment, anyone hitting that endpoint, so say I was running this in production, anyone hitting that endpoint would be rerouted to my local machine. Yeah, might be fine in, like early days of a startup. Obviously, if you're running at scale, you don't want everyone hitting your laptop when you hit the URL, right? So ideally, you want to be able to selectively intercept traffic. So if I just go back to my IntelliJ, I'll stop this. I'll bring up my terminal. I'll just do Telepresence leave on the intercept I've set up. Now we'll off. I now do Telepresence status. That should have disappeared. Looks good. I'll do a Telepresence now login to our cloud. Ambassador Cloud, that pops up. Standard login asks for like GitHub, GitLab, Google. I'm going to log in with GitHub, I think. And I'll do AIR DCP. This is our service catalog product, which integrates with Telepresence and a bunch of other services too. If I just bring there, all looks good. So now I'm logged in the there. Extra functionality is available to me. Looks great. If I just clear the screen and do the same as what I did earlier, Telepresence intercept data processing service port 3000, hit return. It's now asking for additional details regards to the ingress. This is just setting up so we can pass down header variables. So you need to, in order to selectively intercept, you need to make sure header, like the Telepresence intercept ID header, which I'll show you in a minute, is propagated down the stack. So we're just configuring the ingress to set that up. Because I'm using Ambassador, it's kind of like baked in, because Ambassador is one of our tools as well. So I'll just say, yes, looks good. I'm running TLS. I am running on port 443, and I'm not using any multiple hosts or any SNI, so just keep it super simple. Just answering yes to all the default questions. Any ingress you've got spun up, this should work with it as well. You need to make sure in your application you are propagating the headers. Feel free to ping me in the Slacks or on the interwebs when you find me if you're not sure about how to propagate headers. If you're using things like distributed tracing, you're probably propagating headers already down through the stack. But for Telepresence, for selective intercepts, you need to do the same thing. And you can actually see here on the extra metadata I've got here now, it's saying intercepting HTTP requests that match these headers. So any call I make against main ingress now with an X Telepresence intercept ID header set with this value will be routed to my local machine. And to make it even easier for you, we've actually set up what's called a preview URL here, and which includes the injection of the header automatically. So if I just copy that new preview URL we've got there, I'll make sure I'm running my service in debug mode. Looks good. I'll just put into my browser now that I'll load up that preview URL. You can see my breakpoint's been hit. I return. It'll be in blue because we've restarted the app, right? So I can now code away here, super fast feedback loop. I could share this with you as well, right? And this is where the cloud service comes in. I can actually manage who's got access to this preview URL. So you can either do it completely isolated in your own little world, only you have the preview URL, you're making changes, and you're not really impacting other people in the cluster. So you can share a cluster, right? Multiple developers, all intercepting different services, the same services, that's fine. As long as you're not manipulating data stores and doing other kind of things like that, you won't step on each other. So you have one shared cluster, all these intercepts to your local machine, getting those fast feedback loops. And the cool thing is, because we are doing these personal intercepts and we're doing these header-based routing, right? Because I am propagating the header from ingress to Java service to data processing service. If I now hit my main URL, this one earlier on, right? Refresh, it's going to be green. Because as anyone who now hits the main URL, the main remote ingress URL, does not go to my local machine because we're selectively intercepting. Anyone on the main URL will not route my local machine unless they manually set the Telepresence intercept ID header. Yeah, and with the preview URL, we just do that for you. So the preview URL, I'm coding away. I might share with a colleague and say, hey, I fixed this bug. What do you think? And they would look at the preview URL. Looks good to me. Pass it through in debug. And folks using the main site are completely unaffected. They're just hitting refresh. They are not hitting my local machine. Simple as that. So that's the value you get. Like I say, with the when you log into the cloud, you get the additional functionality of being able to do these personal intercepts or shareable intercepts, and you can manage them. You can actually see them in the cloud as well. If I just go all services, just find data processing service. I think it's, where is it? Oh, there it is. Yeah. So I just click on data processing service. We can see in our HUD down here, I've got one personal intercept running. If I click details, I can see the details of the intercept. And if I was to share this with you or share this with my colleagues, we can see who's watching, we can see who's using the URLs, and we can control access. That's the beauty of the cloud product, providing that level of sort of visibility and control over the intercepts there. So that's pretty much it. I know we're a bit tight on time. Again, apologies for the slightly late start on my part there. That's the beauty of telepresence. Not only can you do intercepts, but you can do remote volume mounts. If you've got SSHFS installed, you can see I haven't on this machine. Actually, the warning here. But you say if you're loading TLS certs or secrets or something like that into a volume in your remote Kubernetes cluster, we can mount it locally using SSH. Sorry if I say it right. SSHFS locally, so you can access the volume locally as if you were in the cluster. We can extract environment variables from the remote cluster, so you can spin up, say, IntelliJ. There's a cool plugin called the env file plugin, and you can just load in all the remote environment variables into your local copy of Telepresence. So I definitely encourage you to pop along to the docs. I think if I just do get ambassador, docs Telepresence, right? There's lots of interesting docs here. You can, like I sort of hinted at earlier, say you've got like remote MySQL databases or Kafka or something running in cluster. If it's domain name addressable, you can make sure you can route to that from your local machine. You can also selectively route like certain CIDR blocks. So if you've got certain things that you always want to route to the cluster from your local machine, you can do that as well. There is a lot of flexibility with Telepresence. And again, the code is open source on GitHub. Pop along to GitHub, have a look around, get chatting to the engineers there. You can do pull requests and have a chat if you know something's there that you don't. So something's there that you want, or something's not there that you want. Have a chat with folks. We've got a Slack, a8r.io/Slack. That's a8r.io/Slack. You can jump in Slack and also ask us a bunch of questions there and these kind of things. But I hope this has been useful. I'll just fire up my last slide in the last few minutes. I just exit that, scroll down. I'll skip over the workflows. I'll share the slides with you later. The workflows we can cover it. What I'll do now is with the time, I think I'll say straight to the conclusion, and then do play in Windows. There we go. So just to recap, the inner dev loop can be super painful when you move to microservices and cloud and Kubernetes. There's more services in the mix. There's more layers of infrastructure. Telepresence proxies your dev machine into the cluster, increasing that fast feedback loop, right? You don't need to Docker build, Docker push. You can just access remote services, and you can intercept traffic to your local machine for testing purposes. Lots of workloads. I'll share the slides later. You're limited by your imagination, but basically in terms of some folks are putting Telepresence in their CI/CD or in their continuous delivery, build pipelines to be able to share clusters. Like one cluster, Telepresence in with a service, run some tests. There's a whole bunch of interesting use cases here, right? And again, it's a CNCF project. The CNCF is amazing. They provide us a neutral home, right? IP governance. They help us kind of get the word out about Telepresence, but it's a fantastic tool. But it relies on the community. It relies on your feedback, on your support. There's lots of ways to get involved. Documentation, definitely a key thing, right? Explaining how you integrate Telepresence into your workflow, just bug fixes on docs. Let us know if you're a user, triage bugs. There's lots of folks on GitHub asking for things, which is awesome, but hard for us to scale sometimes. And you can join the Slack as well. We'd love to see you in the Slack asking questions. We monitor the Slack, a fantastic community in the Slack too. That's it. I think I've got a few links here. I've done some blogs on the IntelliJ website, JetBrains site, with some Java theme ones. We've got some Go. Peter, my colleague, did some Go blogs. We've got some other blogs kicking around as well. If you want to know specific language-specific examples, hit me up. I can point you in that direction. Lots of folks are using Telepresence for all different kinds of languages. And we do run office hours at Ambassador Labs, so you can jump on and chat to us more there, like via a Zoom chat. And you can also hit me up on email or most of the interwebs at Daniel Bryant UK. Again, love getting involved in Twitter in particular. I shall pause at that point. I think we're almost out of time, but I'll have a quick look on, there's like a 30-second question. Oh, Marcus, great question, asks, does it still work with network policies? So network policies operate at sort of like layer 3, layer 4, right? Quite low level. So depending on the config, sometimes the answer is no, right? The two things that Telepresence is limited by is RBAC. So if you can't get access to the cluster by kubectl, that's a non-starter. And with network policies, the restrictions are honored. Telepresence, my understanding, sort of does no extra magic there, right? There's no like security kind of workarounds or whatever. If network policies restrict a service in the cluster accessing another service, for example, Telepresence will respect that. That's sort of part of it. We do integrate with service meshes as well. I get that kind of question. There's a Linkerd example. Nick Jackson and I from HashiCorp are doing a talk in a couple of weeks' time around console integration. So if you're check out DevHouse, it's our Colo event with KubeCon. So if you Google around for DevHouse, Nick Jackson and I are going to show Telepresence with console service mesh. And I know the Istio folks. I know we have people in production using Istio and Telepresence too. So same kind of thing. If you've got layer seven like security policies within your service mesh, Telepresence will honor them too. Cool. Thank you, Matthias, for the feedback. Great stuff. And apologies once again for the streaming issues. There's plenty of other, let's say, resources I can share with you. If you do want to know a bit more, just let me know. Thanks very much.